Okay, this is lesson 3.4. We're going to change gears a little bit with this lesson. We're going to talk about graphing. So for the next two lessons, we're going to talk about graphing. And today, the objective is students will graph quadratic equations written in the standard form. So today we're just going to talk about all the standard form. And the next time we'll talk about how to graph in a different form. And we'll talk about that a little bit in just a few minutes. So this is the standard form of quadratic equation. It's y equals ax squared plus bx plus c. Now what's important to remember is when I ask you for a, b, and c, they don't actually include the x. The a is there's a coefficient that goes with the x. But anyway, when we look at this, c is called the constant term because it's a constant, there's no variable in there. B is called the linear term because x to the first power, whenever you have that, that makes a linear equation. And the ax squared is called the quadratic term because when you have x squared, that makes it a quadratic equation. When we graph a quadratic equation, it takes this shape. It looks kind of like a U that gets stretched upwards. This shape is called a parabola. And I'll say that again, a parabola. All of the quadratic equations are going to have this shape. One of the things that's nice about a parabola is it's always symmetric. So I have that dotted line going down the middle. That's the axis of symmetry. In this case, it's x equals 2. And the parabolas we'll deal with today, they're all going to be up and down or down and up. They won't be sideways or turned crooked or anything like that. So the axis of symmetry will always be a vertical line. So it's always x equals some number. Another important thing to know for parabolas is this point right here where the parabola starts going down and starts going up. In this case, it's the minimum of the function. That point is called the vertex. And the vertex for this particular parabola is 2, 2. Since it's a point, it has coordinates. The vertex is the most important thing we're going to have to know when we're graphing the parabola. This particular parabola has the leading coefficient a is greater than 0, and I know that because it opens up like a cup. I had to go over that stuff for another parabola. Here's a parabola here. This parabola is a little bit different. The axis of symmetry is at x equals negative 3. The vertex is at negative 3, 1. And this one opens down. So I know that a, the leading coefficient, is a negative number, or a is less than 0. So we have ax squared plus bx plus c, is the standard form. And here's an example of a problem written in standard form. So we have x squared minus 4x plus 5. Here's another equation. This is x minus 2 squared plus 1. This equation is not written in standard form. You don't see that ax squared plus bx plus c going on. So if you have a good equation like this, before you graph it, I want you to put it into standard form. And to put it into standard form, let's expand the x minus 2 squared. That's x minus 2 times x minus 2. Remember, it's not x squared minus 2 squared. That doesn't work. You have to FOIL. So when I FOIL this out, I get x squared minus 2x plus 4. And then I still have the plus 1 on the outside, so that doesn't go anywhere. Now I can combine like terms. The x squared doesn't go with anything, but the 2 minus 2x's combined to give me negative 4x, and the 4 and the 1 combined to give me 5. Oh wow, look at that. You'll notice that those are the same equation. So that x minus 2 squared plus 1, that's actually the same equation. It will give me the same graph as x squared minus 4x plus 5. It's just two different ways of writing the same thing. That green equation, and we'll find this out next time, is vertex form. We're not going to worry about that right now. We're going to worry about standard form, which is the red equation. So what we're going to do when we have this is the first thing we need to do is we need to find the vertex. So for this particular problem, I'm going to find the vertex. And I have this really fancy math way of writing that. Now what that means, and you can just kind of ignore it if you don't understand what that means, that's the technical math way of writing it. What this means is in order to find the vertex, I have to first find the axis of symmetry. In order to find the axis of symmetry, I use the equation negative b over 2a. Negative b over 2a, once it gives me the vertex, gives me the vertex is also, axis of symmetry is also the x-coordinate for the vertex. So whatever my axis of symmetry is, I plug that back into the original function, and that's going to give me the y-coordinate for the vertex, and then I'll have the entire vertex. So in practice, we have a 3x squared plus 12x plus 8. The first thing I have to do is negative b over 2a. b is 12 and a is 3. So negative b over 2a is negative 12 divided by 6. which is negative 2. So the axis of symmetry, which is also the x-coordinate for the vertex, is negative 2. To find the y-coordinate for the vertex, I plug that negative 2 back into the function. Like this. All I do is replace all the x's with negative 2. When I do that, remembering to do exponents before multiplication, that's going to give me 3 times 4 minus 24, because 12 times negative 2 is 24, plus 8. I do negative 24 plus 8, and it gives me negative 16, and 3 times 4 is 12, so I have 12 minus 16, which is negative 4. So the coordinates for the vertex for this particular problem are negative 2 and 4. This highlighted part is the most important thing we have to remember from this page, and in this whole lesson. The x-coordinate for the vertex is negative b over 2a. Now to graph the whole thing, and this is a new problem, to graph the whole thing, the first step is always to find the vertex. And the first step of finding the vertex is finding the x-coordinate, which is negative b over 2a. So in this case, negative b gives me negative 4, and 2a gives me 4, so negative 4 divided by 4 is negative 1. Then I plug negative 1 back into the equation. I get negative 1 squared is 1 times 2 is 2, plus negative 1 times 4 is negative 4, so I have 2 minus 4 minus 2. That gives me negative 4. So the vertex in this case is negative 1, negative 4. So I plot the vertex. There it is down there, negative 1, negative 4. Then I choose the two numbers to the right of the two x-coordinates to the right of the vertex. So if negative 1 is our vertex, the next two numbers are 0 and 1. And I make a table with that. And I'm going to plug in 0 and plug in 1 and find the y-coordinates for each of those points. 0 is pretty easy because that means the first two terms are both 0. So all I'm left with is negative 2. So then I plot that point. Then I can plug in 1, and that gives me 2 plus 4 minus 2, which is 4. So I plug in 1, 4. And I use my knowledge that this shape is going to be a parabola, and I connect the points. Now I use my knowledge that this is a symmetric equation, and I draw it the other way. And there I have my parabola. Another example, this one's negative x squared minus 4x plus 1. So the first thing I need to do is find the x-coordinate of the vertex by doing negative b over 2a. And in this case, since b is already negative, negative b is going to be positive 4. So I have positive 4 divided by 2 times negative 1. A is negative 1 because I have that negative in front of the x squared. So I have 4 over negative 2, which is negative 2. Then I plug negative 2 back into the equation, and I'm going to get 5. Because I get negative 2 squared is 4, but I take the negative of that, so it's negative 4. And then minus 4 times negative 2, which is going to be a positive 8. So I have negative 4 plus 8, which is positive 4, and then plus 1, which is 5. So I go ahead, plot the vertex. Then I make my table. In this case, since the vertex is at negative 2, my next 2 points are going to be negative 1 and 0. Just keep going up the line. Negative 2, negative 1, 0, just like you're counting. When I plug in negative 1, that's going to be negative 1. This is going to be, the first term is going to be negative 1. The second term is going to be positive 4. The third term is going to be positive 1. That adds up to 4. And I actually plotted the points in the wrong order, so don't look at them. And then I plug in the 0, it's going to be 1. Because the first two terms are going to be 0. So I have negative 1, 4, and I have 0, 1. I connect those with the idea that I know it's a parabola, and then use the idea that it's symmetric to draw it going the other way. And that's my finished graph. So I wanted to show you one more thing, and I wanted to show you that you can actually use this graphing to solve a quadratic equation. In this case, I have x squared plus 4x plus 3 equals 0. Now remember, in all the other ones I had before this, I had x squared plus 4x plus, I would have had x squared plus 4x plus 3 equals y. But I'm going to do that first. I'm going to treat it like it's x squared plus 4x plus 3 equals y, and I'm going to graph it. The 0 will come back later. So the first thing to do is find the vertex, which in this case is negative 4 divided by 2, which is negative 2. Then I plug the negative 2 in, and I'll get negative 1 for the y-coordinate, because we're going to get 4 minus 2 plus 3. Then I plot the vertex. Now I use the axis of symmetry, negative 2, and I plug in the next two x integers for my table. That's going to be negative 1 and 0. When I plug in negative 1 of the equation, I'm going to get 1 minus 4 plus 3, which is 0. Then I'm going to plug in 0, and I'm going to get 3 because the first two terms are going to be 0. and I'll plot those 2 points as well. Then I draw the right-hand side of the graph, then I copy that onto the left-hand side. Now I want to solve the equation. I want to know where the y, remember we graphed x squared plus 4x plus 3 equals y. And I know from the equation at the beginning that I'm looking for where y equals 0. Well, remember, any place on the x-axis, the y coordinate is going to be 0. So we want to know where this graph crosses the place where y equals 0, which is the x-axis. And in this case, it crosses that x-axis where y equals 0. It crosses it twice, once at -3 and once at -1. So those are the two answers for this quadratic equation. If you wanted to solve that by factoring to check your answers, you certainly could. You would get -3 and you would get -1. So that's the end of the lesson. I have 6 graphs for you to make on page 58. I would recommend you use graph paper. It's going to make my life easier grading, but it's definitely going to make your life easier trying to make these accurate graphs, especially when you have to replicate this on the test. So this will be your first homework assignment due second quarter. So, let's get a good start on it, and good luck, everybody.